Okay, so we are to look at our last question on this particular set of tutorial. Then we'll continue later on other subheadings and subtopics. And so we are asked to draw a Cayley table of S3 and use it to find I, the centralizer of this particular element, and II, the center of S3 of the symmetric group of S3. And so this is going to be very lengthy, but we'll try our possible best to make it shorter. The idea is to know how to work it out, and once you figure it out, you should be able to do it. So S3 has just 3 elements. So the thing is S is equals to 1, 2, 3. And so we want to use this to form S3. And you know that S3, that's just going to be there. Since there are 3 elements, so S3, and you know what the order will be. The order, since there are 3 elements, that will just be 3 factorial, and that's 6. So we have 6 elements. And how do we find this element? Well, that's simple. Each element is going to have 1, 2, 3 at the top. 1, 2, 3. 1, 2, 3. 1, 2, 3. They are going to be 6. 1, 2, 3. That's 5. 1, 2, 3. That's 6. 1, 2, 3, 4, 5, 6. Good. So 1, 1, 2, 2, 3, 3. So here the first element will just possibly be 2, 3. That's the identity element, which is always simple. Now when we come here, that will be 3, 2. Here is 2. So you can take 2, 1, 3, and then 2, 3, 1. This is 3. So 3, 1, 2, 3, 2, 1, like this. And so we are done forming our groups. So which we can actually write. So this one, writing as a circle, everything is fixed. Everything is fixed. And so we don't need to do anything. But when we come here, 1 is fixed. So here we can write it as just 1. That's the cycle. 1 is fixed, but 2 goes to 3 and 3 goes to 2. So that's 2, 3 for that. Here 1 goes to 2, goes back to 1. So I have 1, 2. But 3 is fixed. Here we have 1 goes to 2, 2 goes to 3, and goes back to 1. And so we have 1, 2, 3. Here we have 1 goes to 3, 3 goes to 2, 2 goes to 1. So 1, 3, 2. And here we have 1 goes to 3, 3 goes to 1, 2 is fixed. So 1, 3. So these are our cycles. So we have to draw a Cayley table. We have to draw a Cayley table for this. And that's going to be daunting, but we'll try our possible best. So we have the identity element as usual. We have 2, 3. We have 1, 2. I'm going to bring the smaller ones first. 1, 3. 1, 2, 3. And then 1, 3, 2 for this element. Okay, so we have 1, 2, 3. We have 1, 2, 1, 3, 1, 2, 3, and then finally we have 1, 3, 2. So in order to do the compositions, of course, for this line is, you know that this one is the identity element, so we don't need to suffer filling this part. So the same thing, so 2, 3, 1 2 1 3 1 2 3 1 3 2, and here to the same thing, so 2 3 and 1 2 1 3 1 2 3 1 3 2. So the problem then arises if we want to compose this man to this man. The thing to itself, 2 3 to 2 3, and 2 3 is this element 1 2 3 3 2. So we want to compose it 1 2 3, so 1 3 2 by itself. We want to compose it by itself 1 2 3 1 3 2. So composing 1 2 3, now 1 goes to 1, 1 goes to 1, so here's 1. 2 goes to 3, 2 goes to 3, 3 goes to 2, so we have 2 here, and then 3 goes to 2, 2 goes to 3, we have 3 here, so we get the identity element for here. So we get 1 here. Now we compose that same thing 2 3 with 1 2. So we have 1 2 3 1 3 2, composing with 1 2 is 1 2 2 1 3 3, 1 2 3 1 2, I think it's 2, 1 3, yeah, this is our 1 2, yeah, I'm taking it from this point, this place, okay, yeah. So I come back and compose it. So to compose, I have 1 2 3, which are just the normal headings, but here 1 goes to 2 in this particular bracket because we compose from back. Then when we come here, 2 goes to 3, so that is the down element for the first number. Now 2 goes to 1, when we come here 1 goes to 1, so that is the answer for the second number. 3 goes to 3, when we come here 3 goes to 2, so that is the last one. So writing this as a cycle, 1 3 2 1, so we have 1 3 2 as the answer. So here is 1 3 2. So this is how we compose. So I'm going to cut it here. Now that you know how to compose, then I'll fill the table, then we'll come back and check. Okay, so this is our complete Cayley table which we have formed, and so we are expected to use this table to find some answers. And what are those answers? The centralizer of 1 through 3, and then the center Z3 of the symmetric group of S3. So what do we mean by centralizer? Well, centralizer is all the centralizer are all the elements which commute with the particular element that is given. So we are given the element 1 2 3, and so it means that we are going to compose this particular element with all the elements in the group to see which of those elements that commute with it. In other words, when we change the position of the element with all the other elements, do we still get the same answer? That is the question we have to ask. So all those elements which gives us the same answer when we change their positions are the centralizers of 1 2 3. So that is what the question is asking us to do. So so that's the I centralizer of 1 2 3. And so if we operate this with all the elements, well, let's see. I'm going to use a different pen. So if we come here, if I operate 1 2 3 this element with 1, I'm going to get 1 2 3. Now if I operate 1 with the same thing, I'm going to get 1 2 3. Good. So that works. Now let's come. If I operate 1 2 3 with the second element, I am getting 1 2. Okay. Now if I operate 1 2 with 1 2 3 I'm getting 1 2 again, and so that is also a centralizer. So it means that 1 2, if I operate 1 2 3 with 2 3, I get 1 2. If I operate 2 3 with 1 2 3, oh, I don't get 1 2. There's an error. I don't get 1 2. Here's 2. I don't get 1 2, but I get this. So it is not a centralizer. Now if I operate 1 2 3 with 1 2, I get 1 3. Now if I operate 1 2 with 1 2 3, 1 2 with 1 2 3, I get 2 3. You see? So the answers are not the same. So when I operated it with this, I got this. But when I operate it with this, I got this. So the answers are not the same. So that means it is not a centralizer. Good. Now let's come to the third element. We are operating 1 2 3 with 1 3 this time. So let's see. If I operate 1 2 3 with 1 3, I get 1 3 2. Now operate 1 3 with 1 2 3. 1 3 with 1 2 3. I'm getting 1 2. So they are not the same. 1 2 3 to this one, I get this answer. But 1 3 to 1 2 3 here, I get 1 2 here. So this one and this one are not equal. So it is not a centralizer. So 1 3 is not a centralizer of 1 2 3. So let me take it off. Now we go to the fourth element and the fifth element. And so the fifth element, let's see. So we are taking 1 2 3 and operating 1 2 3, and we get 1 3 2. 1 3 2 here. Now let's take 1 2 3 operate itself, we get the same 1 3 2. So that also works. So it is a centralizer of itself. Now let's take 1 2 3, which is what our element is. So far we've got the identity element as the first centralizer. So the identity element, which is this one, and now we've got the element itself, which is this one. Now we are going to test the last one to see. So now let's see. If we test 1 2 3 again, going to this element, here, we are getting 1. Okay, now 1 3 2, this element here, going to 1 2 3, going to this element here, we are getting 1 as well. So we got these answers which are equal, and so we can see that this element here is also part of our centralizers. This one here is also part of, so this one works, this one works, and this one works. So the centralizers include these elements. So the first element, the element is a 1 2 3 and then 1 3 2. They are the centralizers of this element, so take note. Now the center, well, for this particular table, if we look at it, the center is the particular element which commutes with all the elements in the group, and so the identity, which is this, is always a center of that. So the center z s3 equals to the identity element, because that always commute. Apart from that, with the permutation groups, they don't commute like that, except only a few of them. And so some of the elements have centralized, but not all of them. All of the centralizers commute with all the other elements, so it doesn't work that way. So but the identity element commute with all the elements. If you change the position, it always gives you the same answer as the original one that is used, or the element itself that is used. It doesn't matter where you kept the identity element, you always get the same thing. And so we are saying that the centralizers of 1 2 3 are this, and the center of the group is this. Thank you for watching. Kindly subscribe. We'll end here. If you have any inquiries, you can kindly comment so that I can see your inquiries, your problems. You can send them to me. Thank you for watching. Kindly subscribe.